Okay, implicit differentiation. Implicit differentiation. Just as a side note, I don't I don't really guarantee any of the spelling on some of these. So you know us math people, sometimes we misspell stuff. So always double check, but I think that's it. Okay. All right, implicit differentiation. Oop, adjust this a little more. Okay, so here's the deal with implicit differentiation, and it can seem the notation of it can seem a little bit confusing, but there's one rule that I usually use when I do it that I find helpful, and that is you will perform the differentiation on everything just as you would normally, with one exception. If there is a y variable, then after it you have to multiply it by y prime. And the reason for that goes back to the chain rule. Um, but let's take a look at this. That's kind of like the one basic rule that if you remember and if you follow, then you'll pretty much be okay with most of the problems. So let's take a look. Let's take a look at what I mean by that. So let's say you want to take the derivative of something like sine y equals x. All right. So again, just looking at this practically with the one rule that I just mentioned, I know that the derivative of sine y is going to be cosine y. So the derivative of sine y is cosine y, and because this has a y, all I'm going to do is I'm going to multiply it by y prime, or I'm going to add a y prime at the end of it. Moving over here, x, there's no y here. It's just an x. So I just take the derivative of x like I would anything else. So the derivative of 1x, that just equals 1. And once I get to this point in implicit differentiation, it's just solving for y, or really y prime. So looking at this, well, I know if I divide each side by cosine of y, then I can get rid of that. And so I know that my dy dx, which is another way to write y prime, that's kind of the shorthand way, is going to equal 1 over cosine y. So really what most of implicit differentiation turns into is just algebra, just solving for this y prime. But keep in mind my one rule. All you're doing if you're solving for a y, or if you have a y and you're differentiating, is you just multiply it. So you would take the derivative just like you would anything else, and then you're just going to multiply it by a y prime after it. So let's take a look at that again, maybe in another example. Let me write an example. Here's another example. All right, let's do one with a few more y's. How about we have y cubed plus y squared minus 5y minus x squared equals 4. All right, there's a few more y's here. Okay, so on this first one, like I mentioned earlier, you're just going to take the derivative like you would normal. The derivative of y cubed is going to equal 3y squared. And because that's not an x, I have to multiply it by y prime. So I have to add the y prime in there. Same thing with this one. The derivative of y squared, well, that just equals 2y. And because there's no x there, I got to multiply it by y prime. Derivative of negative 5y is negative 5 times y prime. Here we go. Now I'm to an x. So I don't have to write x prime on this one because I'm taking it with respect to x. So the derivative of negative x squared is negative 2x. And the derivative of 4, that just equals 0. All right, now I'm in business. So let's take a look at a technique. What I'm going to do, I got a bunch of stuff with these y primes on it. So because I have those, I'm going to take these and I'm going to move them out. I'm going to factor them out to the front. So I've got y prime times 3y squared plus 2y minus 5. And then I'm going to go ahead and add 2x to each side. So that equals 2x. And now it's, again, just an algebra thing. I'm just going to divide each side by 3y squared plus 2y minus 5. So that goes away. And then now I'm left with my answer. So y prime, or dy dx, equals 2x over 3y squared plus 2y minus 5. There we go. And so that's really just the basics of it. Again, anytime you have a y, you just multiply it by y prime. So let's take a look at one more example, because really this goes back with all the other rules that we followed too, the product rule and anything like that. So let's take a look. Well, we might have enough room down here. Let's write this one on the bottom here, because it's a fairly short example. So let's say we have something like x times y equals how about 6x, something random. Okay. If I have something like this, I'm multiplying the two together, but fear not, we have the product rule. So the product rule says, I'll just write it beneath here. I've got, if I'm multiplying two things, I'm going to take x prime times y plus x times y prime. Okay, so not too bad. Looking at this, I know x prime, the derivative in this case of just x, is going to equal 1. So this side's going to give me 1 times y, which is just y. Now on this side, I have x as it is, just by itself, and then the derivative of y. Well, the derivative of y just equals 1. So that's 1. But remember, this is a y, and because I'm taking the derivative of a y, I have to multiply the derivative, which is 1, by y prime. Now the derivative of 6x is just 6, and there we go. So now it just turns into algebra. I've got to get this y prime by itself. So let me go ahead and I'm going to subtract y from each side. So I've got x times y prime equals 6 minus y. And then I'm going to divide by x. So I'm left with y prime, or dy dx, equals 6 minus y over x. There we go. So just keep that one rule in mind. If you're differentiating an x, it's just business as usual. If you're differentiating a y, you differentiate that y, and then you multiply it. You pretty much add a y prime at the end. Then you go back and you solve for y prime, and that's pretty much it. So it's a lot of algebra, a lot of solving for stuff. But the nice thing is once you kind of get that method, it really becomes pretty routine.